Welcome to this session. So in this session we'll study the solubility and solubility product of the salt. What is the meaning of solubility? Solubility of the substance is defined as the maximum amount of a substance which can dissolve in a given amount of solvent at a particular temperature. So at one particular temperature, this given amount of solvent, that is if you say 1 liter, so the maximum amount of a substance which is dissolving in this substance and form a saturated solution is called solubility of a substance. So this is the according for definitions. So at this stage what happens? So this stage actually it is called as the saturated stage, means the quantity of solute which is dissolved is always constant for a given particular solvent at a different temperature. So for one particular temperature, this substance, whatever the amount of solute is dissolved in the solvent is always constant. So on the basis of their solubility, in water, ionic solids are broadly classified into three categories. So there are three categories. This ionic solids we are classifying. That is called soluble solids, slightly soluble solids, and the third is the sparingly soluble solids. What is soluble solids? So they having the solubility greater than 0.1 molarity. So if the concentration of the solubility is more than 0.1 molarity, so they are the soluble solids. If it is coming between 0.01 molarity to 0.1 molarity, then this will be slightly soluble solids. And if it is coming less than this also, that is the less than 0.01 molarity, then these type of ionic solids are called as sparingly soluble solids. Sparingly soluble solids means they have a very little solubility in solvent. So these type of substances are actually sparingly soluble solids are barium sulfate, AgCl, silver, chromium. So they have very little solubility in water. By the way, there is no substance which cannot be soluble. Every substance is soluble. They may be little soluble, something will be there, but it is soluble. You cannot say that there is no substance which is perfectly insoluble. Every substance is soluble. Maybe it may be very, very less, but it is soluble. So when such a salt is dissolved in water, then even in the saturated solution, the concentration of salt is very low. So in that solutions, what happens? The salt concentration of the salt is very, very low amount. What does this mean? This means that when the amount of solute exceeds the saturation point, then it starts precipitation. When it is more than the saturation solution and you are dissolving, then the remaining amount of solute starts precipitating, and then equilibrium exists between the soluble and the insolubles are called solubility equilibrium. Okay, so everything not dissolved, something will be dissolved. So amount of that electrolyte which is going to the solution, solutions undergoes complete dissociation. Why they are going complete dissociation? Because of low concentration, and in saturated solution of such a electrolyte is equilibrium with the ions. For example, silver chloride is added to water. So when you add silver chloride, so what will happen? Some of the substances will convert into ions and remaining will be undissolved electrolytes. So we are talking on the soluble silver chloride which is dissolving and it is converting into ions. That is the silver ions and silver Cl ions. And this silver has some solubility and this Cl also has some solubility. So S is nothing but the solubility of silver chloride, which is nothing but the mole per liter. So as per the law of mass action, concentration of silver plus chloride, product of this one divided by silver chloride. Since it is pure, so we can use a constant term. So active mass of this is 1 because it is independent of concentration. So we will write K into K, that is equal to KSP, and silver plus chloride. So this constant, this is solid constant of cost solid into K, this equilibrium constant, if you multiply it become KSP. So this is the S product of two solubility. So KSP equal to S square at particular temperature. So what is KSP? So KSP is defined as the product of the concentration of ions in a saturated solution of an electrolyte at a given temperature. So for every particular temperature, this KSP value of every salt is different in nature. Now, why these salts are sparingly soluble? So this is one question. Actually, extent of solubility of salt in water is determined by thermodynamics of dissolution. So we will see this concept in thermodynamics. For example, dissolution of sodium chloride in water. So it involves two-step mechanism. So there is two-step mechanism. Step 1, cleavage of crystal lattice. So when any lattice of salt, it cleaved, it is broken down when it comes into solution, and this step is endothermy. Why? Because energy is added to the system to separate the oppositely charged ions. It is energy required to separate the oppositely charged ions, that is sodium plus and silver chloride minus. And also delta S is positive. Why delta is positive? Because ions are set free. These ions are set free and they become motion in solution. So their degree of randomness increases. Second step is what? Ions are hydrated. So cations interact with the positive terminal of dipole water molecule. Similarly, ion interact with the negative terminal of the water molecule. Like this is a positive charge. So this is interacting with the positive negative terminal of the water. Water has a negative terminal and hydrogen has a positive terminal. So all negative terminal is interacting with the water. Similarly, Cl is interacting with the positive terminal of the water. So these are positive terminal. So this step is exothermic, and in this case what happens? Delta S become negative. Why is become negative? Because there is an interaction between ions and water molecules which result ordering of molecules. These water molecules are ordering but in a randomly oriented. So we can see in this step 1. So for this step 1, delta H is positive but delta is also positive. But step 2, here delta H is negative because of exothermy. This is endothermy. And here delta S is negative because of ordering of molecules. But from this analysis, it is failed to predict the sign of the either delta H and delta S for overall process. And hence it will affect the delta G of overall process for each functions step 1 and step 2. Why? Because their signs are opposite nature. So delta H and delta S, these two values, that depends upon the relative magnitude value for the two steps. I have given some examples. From this example it is clear how it is affecting the solubility. So I have taken 4 salts: calcium nitrate, calcium sulfate, sodium chloride, ammonium nitrate. So their delta H, delta S and delta G experimental value has been given here. You can see here in these two cases, one negative, one positive value, but delta G is negative. Here this is negative, this is negative, but delta G is positive. Here this is positive, positive, but delta G is negative. This is positive, positive, but delta G is negative. So from here it is difficult to predict. So we will take the overall process, that is the delta G. Delta G is spontaneous, soluble. Here is negative, soluble. Here negative, soluble, but here is positive. It is non-spontaneous. It is not fully soluble. It is sparingly soluble. Means these type of salts whose delta G is positive, so they immediately establish equilibrium with the ions present in solution, but not completely.